Hey, so hello. Today we're going to do this exam style question. The first part says, show that 3 sine squared theta take away 2 cos squared theta equals 1 can be written as 5 sine squared theta equals 3. Okay, so the first question you might want to ask yourself is, in the answer they're asking us to show, where's the cos squared gone? Well, there's an easy fix, and that's using the identity sine squared theta plus cos squared theta is identical to 1. Okay, then the question is, which of these two do we want to eliminate? Well, we want to eliminate or substitute cos squared for something else because in our answer we have sine squared. So I'm going to rearrange this identity to say that cos squared theta is identical to 1 minus sine squared theta. So now I'm going to replace cos squared theta with 1 minus sine squared theta. So that becomes 3 sine squared theta minus 2 times 1 minus sine squared theta. And that equals 1. All right, and then we have 3 sine squared theta minus 2 plus 2 sine squared theta. My gosh, guys, make sure you're careful with the double minuses. Too many people trip up on that. Okay, then you have 3 sine squared theta plus 2 sine squared theta, which is 5 sine squared theta. Collecting them like terms. Minus 2 equals 1. Then, just to go down here, if we add 2 to both sides, we have 5 sine squared theta is equal to 3. And that's what we were asked to prove. Boom, 2 marks. All right, next part. Hence, solve for theta between 0 and 360, the equation 3 sine squared theta minus 2 cos squared theta equals 1. Look at that. It says hence, so we're using information from the previous part of the question. Previous part of the question was, show that this 3 sine squared theta minus 2 cos squared theta equals 1 can be written as 5 sine squared theta equals 3. It's the same question. So what we're going to do, we're going to start from where we just proved. So I'm going to start with this. 5 sine squared theta is equal to 3. No need to go through this whole long, arduous process again. We've done the hard work. Let's, kick back a little bit. Sine squared theta is equal to 3 over 5 if we divide both sides by 5. Then sine theta is equal to the square root of 3 over 5. Did you forget it? Yeah, don't forget it. Or sine theta is equal to minus the square root of 3 over 5. Guys, when you're square rooting, always remember even that you have the double roots. You have the positive root and the negative root. Okay, so if sine theta equals 3 over 5, let's work with this side first. Let's just draw a line down the middle here. Then we have theta is equal to the inverse sine of the square root of 3 over 5. Okay, that means that theta is going to be equal to, let's just do that on the calculator, inverse sine of the square root of 3 over 5. Man, there's a lot to put in this calculator. Okay, that's going to be 50.8 degrees to 1 decimal place. Why am I doing 1 decimal place? Why? because the question says so. Always read the question. Okay. Then my next step is going to be to work out the other solution. So remember, it was between 0 and 360. So I'm going to draw a sine graph, or as much as what I need anyway of a sine graph. Okay, and then this point is going to be where it hits the top is 90. This point is going to be 180, 270, 360, and this highest point here is going to be 1. Okay, then we draw a line because it was square root of 3/5. It's basically somewhere between 0 and 1, so don't worry too much where it goes as long as it's in between. Draw the line across. The calculator gave us 50.8, which is this value here. So basically, we know that this little gap here, though not drawn to scale, is 50.8. So we also know that the gap between here and this point, because of the symmetry, is also 50.8. Yeah, so if we know this point here is supposed to be 180, and the gap is 50.8, then this point is going to be 180 minus 50.8. So 180 minus 50.8, and that's going to give us 129.2. Okay, let's keep going. Then the next solution is going to be here. So again, by symmetry, the gap between here and here, where the line crosses again, is again going to be 50.8. So that's going to be 360 plus 50.8, but that goes outside the solution, outside the range. So just to show you what that looks like, that's going to be 360 plus 50.8. That's going to give us 410.8. But we don't need that because we were only looking between 0 and 360. So discard that one. Goodbye. So we've got 129.2. Okay, let's not forget the other one. So we've got sine theta equals minus the square root of 3/5. So therefore, theta is going to be sine to the minus 1 of the square root, minus the square root even, of 3/5. And then that's going to give us, so inverse sine of minus the square root of 3/5. And that's going to give us minus 50.8 to 1 decimal place. Now, this is outside the solution, but we need it to help us work out what the other values are going to be. So we again need to draw a sine graph. So let's just go like that. We probably need to extend this graph just because we have the negative, and we draw minus the square root of 3/5, which is again somewhere between 0 and minus 1. So just draw a line like that. Okay, in fact, let me just not make it so confusing and draw that in a different color. So like that. Okay. Then we know that this point is supposed to be minus 50.8. So the gap between here and here is again 50.8. Okay. Let's just label this part again. So this part's going to be for the highest point, which is 90. This is 180. This is 270. And this is 360. So the gap between this and this point here and this point here, let me just do that in a different color, is going to be 50.8 minus 50.8. So by symmetry, again, the gap between this point and this point where the graph hits again is going to be 50.8. So this solution is going to have to be 180 plus 50.8. Okay, so 180 plus 50.8 is going to give us 230.8. All right, let's keep going. So this next solution, again, the gap by symmetry from here to here, just like over here, is going to be 50.8. So it comes before the 360, so we need to do 360 take away 50.8. And that is going to give us 309.2. Okay, so the other solutions that we have, if I just write in the blue, are 230.8 and we have 309.2. Let's take this, the solutions that are within our range, so between 0 and 360. So our final solution set is like this. Theta is equal to either 50.8 degrees, 129.2 degrees, 230.8 degrees, 309.2 degrees. Okay, and that's all to one decimal place. One bit of advice as well, you can check by putting this theta back into your sine equation. So sine of 50.8, should that give you something close to the square root of 3/5? Obviously in your calculator you have to check what the square root of 3/5 is. Check it for 129.2 as well. So do sine of 129.2. Does it give you something close to the square root of 3/5? And of course for these two, the bigger solutions, check that they give you something that's approximately minus the square root of 3/5. It's a foolproof way of making sure that you get your marks. I mean, this is worth quite a lot of marks, 7 marker, so, you know, it's worth it. Right, that's it for this video.